The following video presentation is a part of a series of training aids that were developed for the Certified Aggregate Producer Program through the cooperative efforts of the Indiana Department of Transportation and the Indiana Mineral Aggregates Association. For some specifications, an accurate determination of material finer than the number 200 sieve is required. Material finer than the number 200 sieve can be separated from larger particles much more efficiently and completely by wet sieving than through the use of dry sieving. Normally, this test is used on the test sample prior to dry sieving by AASHTO T11, and the total amount passing the number 200 sieve is the combination of the wet sieving and dry sieving processes. Plain water is normally adequate to separate the material finer than the number 200 sieve from the coarser material with most aggregates. Because clay-fine particles and coatings on aggregates extracted from asphalt mixtures tend to cling to the larger aggregate particles, separation of these finer materials may be aided by adding a wetting agent to the water. However, the addition of a wetting agent is not required. While performing this test, the data may be entered onto the same sieve analysis sheet as a gradation test, and the results may then be calculated. A general-purpose Class G2 AASHTO M231 balance shall be used to weigh all materials for this test method. This balance is readable to 0.1 grams and shall have sufficient capacity for the size of the sample. Sieves shall be mounted on suitable frames designed not to leak and shall conform to AASHTO M92. A nest of 2 sieves shall be used for this procedure. The bottom sieve shall be a number 200 sieve, and the top sieve shall be a sieve with openings in the range of the number 8 and number 16 sieves. All sieves shall adhere to the M92 specification requirements. A pan or vessel of a size sufficient to contain the sample covered with water and to permit vigorous agitation without any loss of any part of the sample or water shall be used. An instrument for agitating the sample is also needed. Usually a cafeteria-style stainless steel spoon will suffice. A mechanical washing apparatus may be used for this procedure, provided that the results are consistent with those obtained using manual operations. Some mechanical washing equipment may cause degradation of the aggregate. An optional rinse bottle may be useful for some parts of this procedure. An oven capable of maintaining 230 plus or minus 9 degrees Fahrenheit shall be used for this test method. When tests are performed in the field where ovens are not available, test samples may be dried in suitable containers over an open flame or with electric hot plates with sufficient stirring to prevent overheating. Samples should be obtained in the field and reduced to test size in accordance with AASHTO T248. The original sample is required to be reduced to a test sample size, which falls within the minimum sample size in the following table. Please note that if the sample is to be tested for gradation in accordance with AASHTO T27, the minimum weight of that test sample shall apply. Also note that if the sample is not being tested for gradation and the nominal maximum particle size of the material is not listed in the table, the next larger size shall be used to determine the sample size. Samples are dried to constant weight in an oven set at 230 plus or minus 9 degrees Fahrenheit in an electric skillet or over an open flame. Once the sample has been dried and cooled to room temperature, the weight should be recorded in the decant section of the gradation analysis sheet as the original weight. After drying the sample and determining the weight, the sample is placed in the container and sufficient water is added to cover the sample. If a wetting agent is being used, the wetting agent is added at this time. The sample is agitated sufficiently to have a complete separation of all particles finer than the number 200 sieve and bring the fines into suspension. The use of a large spoon or other similar tool to stir and agitate the aggregate in the wash water has been found to work satisfactorily. If a mechanical washing apparatus is used, the addition of the water and rinsing agent, if required, the agitation and decanting are done in a continuous operation. Care should be taken not to lose any portion of the water or fine materials during this process. Carefully pour the water and suspended fine materials over the nested sieves. Dispense only the water with the suspended fines and not the sample itself, as that could damage the sieve cloth. Repeat adding the water, agitating and washing the sample several times until a majority of the suspended fines have been washed through the sieves. The washing process is completed when the wash water containing the fines becomes clear. Next, the sample needs to be put back into a pan for drying. First, materials in the agitating container and spoon are required to be transferred into the drying pan. The agitating container is then rinsed out, being careful to not lose any of the fines. A rinsing bottle may be helpful during this stage of the process. Then the material retained on the sieves is transferred to the drying pan. Again, a rinsing bottle will be helpful in removing all of the fines in the sieves. Once all of the retained materials are in the drying pan, dry the sample to constant weight and allow the sample to cool to room temperature. Transfer the cooled sample into a weighing pan and record the weight in the decant section of the gradation analysis sheet as the final weight. Once the original and final weights have been recorded, the decant may be calculated. This concludes our presentation. Please consult your CAP training manual and respective test method for more detailed information.